everybody, welcome back to Quick Chem, and thank you for clicking on the video. So, my name is Sierra, and I've posted YouTube shorts of SN1 versus SN2 reactions and enthalpy and why it's important and everything like that. And I realized I want to do longer videos on Gen Chem, because Gen Chem, everybody has to do it at some point in their life, and having someone that knows how to do it and is someone your age can really be beneficial sometimes. And it was beneficial for me to have an amazing mentor. And I'm currently a freshman in high school, and I have completed a complete honors Gen Chem course ahead of schedule as an 8th grader. So this year I am now doing organic on the side for just some fun. Chemistry is amazing, and I'm going to help you guys. Even if it's not your favorite subject, I'm still going to help you guys learn what you need to get through your high school in order to, do whatever you want to do in your life. So thank you so much for clicking on the video. But right now, what I'm going to be doing is atomic symbols and models. We are going to be learning how to read the periodic table of elements and why it's so important that we do so. And this is just, intro to chem. It's like pre-intro to intro of chem. So I recommend having a periodic table in front of you. It helps so much. And that way, when I'm blabbing along, you can figure out, what's what. Because when you learn how to read a periodic table of elements, it's so crucial for Gen Chem because it is so helpful. And two, it's so helpful. And if you don't know how to read a periodic table, then by the end of the video you will, or at least you'll know some of it, because I'm going to be teaching you how to. That way you don't suffer in Gen Chem. So when you look at a periodic table, you see letters, a lot of numbers, and sometimes it's confusing, like, well, what are these? Like, why do I care about these things? Like, okay, cool. But when you know them and further understanding, it's very helpful. So let's look at lithium, for example, and you see the letters Li. So an atomic symbol is that. It is one or two letter notation used to represent an atom corresponding to an individual element. So if we look at lead, which is Pb is the atomic symbol. Or if we look at bromine, Br is the atomic symbol. And then if you look at hydrogen, it's H, and fluorine, it's F, and iodine, it's I. Sulfur, it's S, phosphorus is P. So it is a one or two letter notation. And then we see the numbers above it, and in the boxes you see a number above this atomic symbol. You're like, oh, well, one, why is there a number there? And two, why do I care that the number's there? So that is called the atomic number. So if you look at tin, which the atomic symbol is Sn, and you look at the number above it, it's 50. So this basically means the number of protons that is in the nucleus of an atom. And then if some of you are like, well, what's a proton? Why do I care about it? It's a positively charged particle, or positively, I don't know. I'm not good at English, but positive charged particle. So if you look at gold, it's 79. If you look at thallium, it's 81. But here we have mercury, and the atomic number for mercury is 80. And then the atomic mass is the number that is right here. And it's kind of, maybe don't do that. It's under the symbol. So generally a pretty, basically a lot of numbers under a symbol. And the atomic number is up either in the corner or right above the atomic symbol. So then you hear me saying, nucleus, electrons, neutrons, protons, and you're like, well, I don't care. Well, this is the structure of an atom. So the structure of an atom consists of two kinds of particles, which one is the nucleus. And again, what's a nucleus? Why do I care about it? And maybe you don't, but a nucleus is an atom's central core. So what goes in there are protons and neutrons, and electrons kind of exist on the outer shell of the nucleus. And when scientists say outer shell, generally you're like, well, why is it called the outer shell? It can also be called other things such as orbitals, and orbital diagrams will be taught much later into Gen Chem. And when you have a nucleus, let's say just you have a circle that represents the nucleus, and then you have like another line, like another circle around the nucleus. Electrons exist on that, and we call it the outer shell because it is obviously the outermost part of the nucleus. The last thing I want to discuss, and we won't really talk about the mass or the AMU right now, and AMU stands for atomic mass unit, but I wanted to put it and include it in the chart. But that will be another video. Most likely the next video I post will be that. And I will be explaining more in depth what is AMU, why is it important really, what is just mass in general, why do I care about the mass of an electron or a proton or a neutron. But the two things I do want to point out today are what are the particles and what are the charges of it. So the first one we have is electron. We can ignore the mass and the AMU for right now. Well, it'll come back next video. But the charge of an electron is -1. And the reason why is because it's a negatively charged particle. And then proton, which is located in the nucleus, has a charge of +1 because it is positive. And neutron has no charge. It is 0. And generally, students who are just getting introduced, specifically like middle school students who are getting like having a chemistry unit or whatever, generally are like, well, why a neutron is negative? And while we understand why they think that, it's also, as you get older, you also understand, okay, I can memorize what is the charge of an electron and a proton or a neutron. Another thing that you guys will encounter, or any Gen Chem student will really encounter, is instead of writing electron in like something in a word problem or something of that nature, teachers will be writing an E-, and it just signifies an electron. It's an E with a negative charge. But I'm not going to bore you guys anymore for today, but thank you for clicking, thank you for listening, and we will discuss more of the atomic mass and the basic metals and the transition metals and the halogens and the noble gases and the alkali metals, like all the different parts of the periodic table next video. But for now, I wanted to lay some basic groundwork of, I'm going to be saying these terms next video, and if you don't know what these terms mean, then you're going to have difficulty understanding more of the more in-depth stuff. But thank you so much, and I greatly appreciate it. I will be posting on Mondays, Wednesdays, and Saturdays, and I hope you guys continue watching. Also, as like the channel, as I post more, I will be creating playlists. So one will be organic, one will be thermo, one will be electro, one will be Gen Chem, and then another one might be, depending, mass spec. So it is all depending. Also, there will be one name just that is named mechanisms, named synthesis, reactions, all of those, because synthesis is the best thing in organic. And who knows, maybe you're like me and you think Gen Chem is amazing too, and you want to challenge yourself. Also, one other thing. Students that don't like Gen Chem generally like organic chemistry, and the reason why is because the Gen Chem is so full. It's very math heavy stuff. You will be learning quadratics if you are in honors gen, and then learning it's basic it's basic algebra at times, and other times you're learning algebra 2 things. So really make sure that you have your algebra on point, and if you need extra assistance, I will be making worksheets and I'll link them in description boxes down below. Another thing is organic chem is nothing like Gen Chem because it's theory based. You are not making calculations. You do not need to memorize these formulas. You are drawing benzene and you are drawing ethers and esters and aldehydes and anhydrides and alkenes and alkynes and all of these amazing things. So if you like the math heavy stuff, maybe you won't like Orgo as much, or if you're like me, you'll end up loving both because you're such a chemistry nerd. And the reason why I will have synthesis and named reactions and stuff as a playlist is because that is my favorite part of organic chemistry. It's the best part of all chemistry ever. So thank you for listening to my, long lecture. I'm sorry you had to sit through that, but thank you for clicking on it. And I'm going to stop now because, but thank you for listening, and I hope this helped give you guys a general understanding of the periodic table and particles. Thank you.